am Vele Keppes. I'm the head of Material Science and Engineering here at the University of Tennessee, and I'm sitting here in one of our undergraduate teaching laboratories. I'm joined by some important people in the department. I'm going to let them introduce themselves, and I just want you to know we're all very excited to tell you some more about material science and engineering.
Hi, I'm Hannah Raines, and I am the academic advisor for material science and engineering. I help students plan courses and support them in their academic journey and make sure that they get connected to the resources and opportunities they need to be successful here in material science. And so we're going to do a brief question and answer panel. We're going to start with this with a few of our MSc ambassador students and a faculty member. So I guess we will start by letting them introduce themselves, and students, if you just want to share your hometown maybe and what year you are, but we'll start with our faculty member.
Well, hi, my name's Chris Wetland, and I'm a lecturer in material science and engineering, and I teach all the laboratory courses, and I'm really proud to say that our courses are very hands-on, and we really want you to come into our department. We want you to start using things, we want you to start breaking things, and just having an absolute great time learning by doing. So another important job I have is that I like to try to find you undergraduate research opportunities. So I found Madeline several research opportunities and maybe some more at some point, and that's one of the jobs that I enjoy doing the most, is trying to find you a chance to do some undergraduate research.
I'm Madeline, like he said. I'm a senior at the department, and I'm originally from Maryville.
I'm Cameron. I am also from Knoxville, and I'm a junior in the MSc department.
Wait a second, are you from Maryville or Merville?
No, I'm from
Okay, I thought it was Merville because that's where I live too. Okay.
I've heard Maryville personally. I'm a sophomore at the department, so I'm the baby of the group, and I'm from Knoxville as well, so I have a bit of experience with the Maryville pronunciation.
Okay, and so our first question is a pretty basic one that I will pitch to Chris, but feel free to weigh in if you have some insights to share as well. But the first question is, what is material science?
So, material science is probably one of those fields where I think that almost all the other fields are doing it, but they're just kind of calling it different names. And I like to think of material science as starting with atoms. And I think that we like to think of chemistry and physics first in our department. And we like to understand how atoms talk to each other. And the properties that atoms have when they talk to them on the short scale are one such type of property. But then when we start adding atoms and they start talking in even greater three-dimensional like scales, they're going to take on a different set of properties. And I think as material scientists, we want to understand the range of properties when we just have a couple of atoms together versus if we have lots of atoms sticking together. And trying to understand the structure, the properties, and how to make everything put together is what I think material science is. I'm interested to hear what you guys think material science is.
I just add in, we work with three main branches. That's metal, ceramics, and polymers, so those plastics and rubbers. Figure out why they act the way they do, but other things do that as well.
Yeah, I think you covered it pretty well, just looking at the structures and the processing and how that affects the properties of the material. It's really what we look into.
And I think one thing that's important to remember about material science is it's not just science, it's also engineering. So we do look at the structure and sort of the science and the theory behind everything. But
and the applications, right?
And the applications, exactly. So we take that and we try and put it into the real world scenarios and things of that nature.
And I will often tell people like material science is like the bridge between your basic sciences, physics and chemistry, and the applications in the real world. And that bridge is pretty long, and you can be on either side of the bridge. You can be very close to the basic sciences if that's where your heart lies, but you can also be really working on the application side if that's where you're most interested in. So anything is possible in our field.
So my next question is for the students. Why did you choose UT?
Well, I guess I'll start then. So I chose UT because it was close to home. That was a major advantage for me. But also the material science, I knew I wanted to do material science in college, and the material science program at UT is really great. We have a lot of good connections with Oak Ridge National Lab, and I know Chris has always talked about how well-funded our undergraduate laboratories are. And so just a plethora of opportunities and things to get involved in at the university.
My family had background in Oak Ridge too, so it was important for me to stay close to here so I could potentially work with Oak Ridge. But also, I mean, I grew up here and I know a lot of places I like hiking, and there's a good nature center nearby. And it's hard to leave home, you know, but so I chose UT.
I tried to leave home. But UT is a great program, and like over now are huge. Amazing research facility, awesome opportunities to work there. Good scholarships here. MSc department has a fantastic scholarship program. If you need that, it's wonderful. It's really good just being home if you're originally from here, or if you're not from here. I have a lot of friends who came in who they fell in love with Tennessee, and like it's become home. We're all local, but that's not always the case.
And Knoxville's a great community too. I feel like it's got a lot of. I mean, it feels like a city, but it's also small enough to where you can get to know people and you can get involved in the community, and there's a lot of things to do in town.
Cool. So the next question is, why did you choose to major in material science?
Brian, you want to start with that?
Yeah, sure. I'll take lead. I guess I grew up. I read popular science as a kid and things of that nature. So I always knew I wanted to be involved in a science field. And then I I did a lot of hiking and outdoor activities and things of that nature when I was growing up. And so I kind of got involved in gear and stuff oriented with that. And so I started looking into gear and sort of what affects it and what makes it perform the way it does. And doing that, I kind of had a natural segue into material science because so much of what makes up gear, or really anything in this world, is determined by the materials that go into it. So I choose material science.
I had a similar feel behind it. It wasn't so much looking into gear and outdoorsy stuff, but I was always curious to how things were built up and how we got the properties that we have. And I was really fascinated by metalworking in particular, and that kind of brought me into the MSc department.
I came into the chemical engineering department, but then when I got in there, I realized I loved the chemistry, but missed the physics, and I wanted to know why. It wasn't enough for me to know that it could do this and figure out what it was. I had to know the why behind it. I was talking to a mentor I had at the time with my research, and he actually had a background in materials, and mentioned that the questions I was asking were answered here, which I loved. To be able to come and I was able to look at engineering, which I adore, but I'm also able to get the science behind it and figure out what's happening on that very small scale, which I think is fantastic.
And this question is for anybody. What resources are available at UT to help students?
I know for one, I'm actually a mentor in the engineering mentorship program, so I get to work with some of the younger engineers, help them out, and point them towards different resources if they need help, like the Center for Career Development here at UT. We also have a materials advantage for the materials MSc students. We have a lot of good engineering mentoring programs. That's not the engineering mentorship, but more for studying. If you need help with a certain class, there's a lot of students and or professional people that can help you if you're falling back in your studies, which I think is really nice.
And I think something that shouldn't be understated about the department is the amount of research opportunities that are available. So I know as a freshman it was really easy for me to have access to that. And I know Chris is really good about helping people find potential opportunities, as he mentioned earlier. So I think that's really important to take into consideration.
Oh yeah, and I got into research pretty early on, and I know a lot of the students here are in research. It's actually helped us in our studies that a handful of students will come in with a background in metals or background in ceramics or polymers, and they'll be able to help each other out during the classes, and I think that's really neat.
What does it mean to do undergraduate research? Like how many hours do you work a week? How does it work if you get busy, etc.? So explain to me how that works for you guys.
So what's super awesome is it's like having a job, but it's way more flexible than having a real job, I feel like. So I did undergraduate research over the summer, and for me, I could come in up to 40 hours a week if I wanted to, or less, just depending. I had to make sure I got my work done, obviously, but it is very flexible. And so during the school year, though, as my course load and work has gone up, I've been able to kind of scale back the amount of time I've been putting into research while still being involved and still being a part of that. And my research opportunity has been great. Not only have I gotten involved on campus, I've gotten to use a lot of great laboratories at UT and over in Giant as well. But also, I actually had the opportunity to go to a national lab in Chicago, so I got to go to Argonne National Lab this summer, which was really cool because as a freshman, I had no expectation of doing that. I was just trying to find something to get involved in the summer. But I feel like the department really takes care of the students that get involved.
And can y'all share a little bit about what your specific interests are, or if you are doing any research or have done some research, maybe what you did it on?
So my research started on fuel cells and figuring out how to make platinum more efficient. I was there for 2 years, and then I got more MSE and more classwork heavy, so I left there for a little bit. And then I was able to internship with an airbag inflator company, looking at welds, which was really cool to see that industry side as well.
And that was off campus, right down the road, right?
That was 5 minutes from campus, and it was a fantastic company to work for. I learned a lot there. And then last summer, I was working at Oakland National Lab on corrosion cracking. So there's a lot of research, like kind of the side that I hadn't seen before. And then a lot of, I got over now, so I got to see everything that's happening. So I got to go sit in a 3D printed car and see all the radiation, and it was just a really cool experience to see what was out there that I wouldn't have gotten without that experience.
I actually also did research in welds. I worked with Dr. Lundin, and he does a lot of looking into power generation and piping. So I get to investigate a lot of pipe welds and see where failures could occur and get into like the nitty-gritty about like how failures can happen and what we need to look out for. I'm also started doing some research into newer metals like high-entropy alloys, which are all kinds of cool.
So, and for my research, I actually worked on additive manufacturing of samples and just sort of looking at porosity and how processing conditions affect that. And so what I thought was cool though when I first started getting involved in the MSc department is I didn't realize how broad of a range of things are encompassed by materials science. So I always thought 3D printing was interesting, but I never thought I'd be working with anything like that. And so this summer I had the opportunity to work on additive manufacturing with like high-powered lasers and metals and things like that, which are pretty exciting, especially coming in as a freshman. So.
What I think is also important to note is like I started my freshman year, my first semester here, I knew absolutely nothing about anything, and they were super okay with that and really good at helping me figure out what I need to do from my lack of knowledge. And then going into the summer or now, I don't know anything about corrosion. That's not an area that I've studied before. I was able to do real work there because they were able to teach me and help me as I went. So you don't have to know anything to go into it, and they'll make sure you know what you need to do once you're there, which is really nice. Assuming the same for y'all?
Yeah, for sure. I learned a lot. I didn't go into it knowing a whole lot.
So I think we would like to take you for a little tour of our laboratory. But if there's some folks out there watching and you'd like to ask us some questions, you can go ahead and text those into us, and we can go ahead and try to answer them throughout the course of the rest of our live demonstration here today. And should you ask a question, or if you're interested, we will make you your very own UT. Okay, there we go. We will make you your very own custom UT MSE Power T, and we'll put your name on it, and we'll send it out to you. And hopefully you'd like to come out here and take a visit with us, and we'd love to give you a tour of the department. So since we just started talking about 3D printing, let's go and see what a 3D printer does and how it works. So this is a pretty standard desktop 3D printer. Right now we're printing a very large atomic structure. In fact, what it looks like to me is that we're printing the diamond structure, which is a very common material in terms of use in engineering applications. It's obviously very hard and is used for cutting. And so as material scientists, we're very interested in the diamond structure for lots of different applications. It allows us to do very high pressure experiments. So one of the labs that students do when they first get to UT is that since we want them to understand this whole idea of atom-atom arrangements, is that we make every single student print some kind of crystal structure. And it's a lab they really enjoy quite a bit. And instead of just looking at a structure in a textbook, they get to actually 3D print one, take it home, and think about it 24 hours a day, because that's what we want you to do all the time. So think about material science.
Well, in my case, dropping on the show about 3 times, having to reprint them over and over again, but it was fun all the same.
Okay, terrific. So here's an image of what we would go ahead to do if we wanted to 3D print something. We can draw it using CAD software, computer-aided design, and then we can go ahead and bring it over to a computer, and then eventually all we have to do if we want to hit print, we can come over here after we get it onto our PC, and we hit print, and then it'll send it right over to the printer, and then I think that this print takes about 10 hours. So in about 10 hours from now, we'll have a beautiful diamond structure. So I'd also like to take you over to one of our really terrific undergraduate laboratories where we have some students who are working on an undergraduate lab that's actually in progress. They're looking at sintering some zinc oxide. And so we'll go take a look at one of our brand new, recently renovated undergraduate labs. So we're on the 6th floor of Doherty Hall. And we have 3 beautiful brand new labs here on campus. And the students will pop in between these 3 labs, as well as maybe a couple more on the 2nd floor. So we have, 3 sophomore students? Is that what we have here? All right, well, I'd like you to come on into Doherty Hall. So this is a laboratory that we use mostly for characterization. And I would say that there's easily probably $400,000 to $500,000 worth of equipment in this room. We don't use, for the most part, we don't use really any kit or any kind of teaching equipment. All of this equipment is what you would exactly use if you were in industry someday. So I have 3 students back here. I'd like for them to introduce themselves and then go ahead and take it away, guys.
All right, I'm Ian Greeley. I'm a sophomore, and I'm from Knoxville.
I'm Morgan. I'm from Austin, Texas, and I'm a sophomore.
I'm Tyler Douglas. I'm a sophomore. I'm from Tennessee, and I'm going to talk to you about some MSc. So, today, or for the past couple of weeks, we've been doing a lab, and it's been really fun. We started off with the zinc oxide powder right here, and you can see it right here. And the average size of the powder is about 500 nanometers, so it's extremely small. So what we did is we ended up loading this powder. We measured out 1 gram, and we loaded it into this right here. We threw it in a hydraulic press. We loaded it in there, put this in there, threw it in a hydraulic press, and it pressed it. And what popped out was these zinc oxide pellets. Really, really cool.
So the goal of this was to get some samples that we could sinter. And so sintering, it's a process where we take a solid like this that's formed from like loose powder and heat it up to make it into a mainly solid pellet. So we did some testing here by heating the pellet at different temperatures for different rates in our experiment to determine the change in porosity of the pellet as we heated it.
An easier way to think of porosity is if you think of a sponge, it's got a bunch of holes in it. So just like sponges, materials have pores. And basically we're trying to minimize those pores by heating it in the process called sintering. So we took those samples, we had various samples. So we took them, heated some samples up to 800 degrees, some samples up to 950 degrees, 1100 degrees Celsius, and 1200 degrees Celsius. And once it reached that temperature in our furnaces here, we held it at that temperature for various times, 15 minutes, 30 minutes, and 60 minutes. So when you took them out of the furnaces, they actually, this is what a sample looked like when it was not heated. When it becomes heated, it gets harder, it gets smaller. There's also some discoloration, more of a yellow color. So when we took them out of the furnaces, we measured the densities. So basically what we were trying to do is fill out this matrix right here with different densities. Then our goal was to graph them. There's various ways you could graph them, and each of them are really cool. This first one right here, you can have the density versus a temperature graph. So basically what it'll give you is a line like this. As the temperature increases, the density increases. The goal of it was to show that it would reach this line right here, which is the theoretical density of it. But in experimentation, there's some errors that occur. Sometimes some things go wrong. You might have something that shoots over the theoretical density. You might have something that doesn't even get close to the line. But that's the purpose of experimenting, to play around with it. this is a really cool graph right here. You got your density and your temperatures, and you can actually create bar graphs with the 15 minutes, the 30 minutes, and the 60 minutes. And you'll notice trends in the bar graphs. I kind of just put random bars on there, but you can look for trends, and it's really, really cool. So next, what we're going to talk about is after we did the furnace stuff, we put the samples in a scanning electron microscope. So here at the University of Tennessee, our lab instructor, Chris, instead of asking students, oh, who wants to use this scanning electron microscope, he says, who wants to drive the scanning electron microscope? So, who wants to drive?
I do. Okay, so in our scanning electron microscope right now is a sample that we sintered for about 950 degrees Celsius for about 60 minutes. And so right now we're about 25,000 times magnification, and this is kind of what it looks like. So like Tyler's saying, it's a sponge. You can see all these tiny little pores in here. But so the next thing we can see is that when you sinter something longer and at hotter temperatures, you end up with a completely different structure. Like it doesn't look like this anymore. So you gotta focus a lot because they're different. But you end up with these things called grains. And these grains, like someone said today during lab, looks a lot like Hawaiian bread rolls. But so each grain has a random shape, and these black lines are grain boundaries. Those are where the grains come together. And so the cool thing about our scanning electron microscope is that we can look at and figure out what exactly we're looking at. If we had an unknown sample, we can just plug it into the SEM, scan it a little bit, and blow it up, and then click on a point, and then it'll start to tell us what it is up there. So right now it's picking up zinc and oxygen, which makes sense for zinc oxide. We're also seeing a little bit of carbon, and that's probably because we have some contaminants that came out of the air and are just sitting on our sample. So we go over here and turn off the carbon, and we can see that the zinc and the oxygen are pretty close to 50-50. And the reason it's not always exactly 50-50 is you end up with some loss of zinc or oxygen, depending on how long and how hot you sinter.
I also think it's really cool with the scanning electron microscope. Even if you have something that you don't know what it is, you can put it in there and it'll tell you what it is. I think that is extremely cool. And just like she said, how some of the elements pop up that could be contaminating it, duster works wonders.
So I'm curious. So we did this lab today in class. So about how much training did you guys get in this microscope? About
maybe 10 minutes.
5 or 10 minutes, and all of a sudden you're sitting over here and you're completely operating this equipment by yourself.
For sure.
And this is something that we're very interested in you doing in our department. We don't do any demonstrations for you. You can see right here in just one day, all the students are sitting down on this instrument and they're able to completely operate it by themselves. And sometimes things don't go great and we have accidents, etc., but that's part of learning, and that's one of the hallmarks of being in the lab and doing really great hands-on research. So, did you guys want to say anything else about some of our experiences in terms of undergraduate research?
Yeah, I'm right now an intern over at Oak Ridge National Lab doing research on high-temperature metals, and I started in September, and I've learned a lot. And one of the biggest things, aside from just like learning science and engineering, is that I'm learning how to work in a lab, and I'm learning what I'm going to be doing with all of my education in a few years, which I think is so cool. But
So since we're talking to you, Morgan, so you're all the way from Texas.
I am.
What made you choose UT?
Well, okay, first I looked at schools that had MSE, and there's really not a lot at all, which I'm sure you know. But so there was Georgia Tech, which I looked at, and it was okay, but I came to Tennessee, and I felt like it was like an entirely different environment. I enjoyed being here. It was a fun department. It's small enough that I know everyone. I'm a second year, and I know everyone in the department already. So it's nice to be able to like, hey Tyler, I need some help. So things like that.
So, Tyler, you haven't had a chance to do any research yet? Or?
I did over the summer, actually.
Okay.
I worked with Dr. Chu, and basically I did a variety of stuff. Reason being is because I did it over the summer, there wasn't a lot of students here, but there were 3 PhD students here. Basically, I helped them out. They were doing 3 different things. basically wherever I could fit in, wherever I could help, I was able to do it. I did some polishing, it was really cool. I actually got to look at some grains over the summer, but not being taught what it was just, I didn't know what it was. But today, learning from Chris, it's really cool actually learning what it is. But yeah, MSc is awesome. Coming out of high school, I actually thought I was going to go to med school. But I decided on engineering. I'm really good at math, really good at science. But I never knew what material science was until I came to Tennessee and we had the engineering day, engineering fair, and I actually went to the material science booth and I fell in love with it. It was awesome. And what caught me was like how personal it is. It's a very small department. Everybody knows everybody. If you ever need help with anybody, there's always someone to talk to. Great teachers, great professors, great students in it, and everybody works together in one big team to accomplish whatever task we are working on. But it's awesome.
Ian, how about you?
Oh yeah, I've got some research experience too. Over the summer I started working at the Scintillation Materials Research Center on campus, and I've been working with them through the fall too. So there I work with scintillators, which are materials that they basically emit light when they're energized by ionizing radiation. So something like that's X-rays. So scintillators can be used for national security, for medical imaging. They're used in stuff like PET scans. And so I started working there this summer and I got thrown right in the mix of it immediately. It's been a great experience, and I've been learning how to not just like prepare samples, characterize them, but also draw trends from what I see in the data. And I'm already working on writing some papers, and I'll be a co-author on 2 different research papers that will be hopefully releasing in the next few months. So it's been a great experience. And I guess I'll answer a question that you asked Morgan. The reason that I chose UT, partially, is its great connection with ORNL. It has a lot of research opportunities that you can take advantage of with a national lab that's just like 30 minutes away. And hopefully next summer I can get an internship there and maybe integrate the research that I've been doing on campus with something out at the national lab.
Well, terrific, guys. So what if someone wants to come for a visit? What can we do for them?
Come join us. You can come see all this yourself. We'll let you drive. We'll teach you all these things. So just come on out, schedule like a tour kind of thing, and we'll take you out for lunch and show you around the department one-on-one.
Well, terrific. Well, thanks, guys. Virla, did you have any other last comments you'd like to share?
I would just say please come visit us, and then, like Morgan said, come see this for yourself. And we have a great crew waiting to take you around and chat with you and tell you all the secrets they don't want to just put on Facebook. So just come see us.
Well, terrific. Thank you all.
Thank you.
Enjoy it.
Thanks.
And thank you.